All right. See if anybody else comes. I forget that there's somebody coming in, let me know. Sometimes I don't look back. Wednesday. And it's kind of like any Wednesday at this point, I think. Except I was just, it was a little weird for me being home yesterday because I've been in school for a while, not teaching from home. So I was like a little off in the morning with my setup at home instead of here at school. So yesterday we wrapped up section 6.1, talking about the rational exponents and simplifying the radicals. So taking that rational exponent, changing it to a radical, and then simplifying it. And also solving some equations that involved exponents. We're going to look at problem 33, and we're going to look at 35 from the homework. We're going to talk about those two. Today, we're going to review properties of exponents, except we're going to do them with rational exponents. So pretty much this section, section 6.2 is what we're going to look at today and tomorrow. Deal with exponents that are fractions and using all the properties of exponents that we talked about in chapter 5, how does that apply to a fractional form? And then of course we still have to do all the simplifying. So you learn section 6.1 so that you can build on it in section 6.2. You do chapter 5 so you can build on it in chapter 6. That's how algebra works. Pretty much that's how math works. So homework tonight is back in the book, 1 through 11 all, and then you're jumping into a couple and then looking at 15 to 28. Tomorrow we'll continue talking about section 6.2, and then Monday we will review for a quiz, more like I guess a quest. I'll call it, I like using that word, mid-chapter quiz. It's not really a test, but it still covers a good bit of material. All of the simplifying radicals, plus the first 2 sections of chapter 6. So that'll be on Tuesday. So if you can take out your homework. As I said, I wanted to do 33, and I want to solve 33 with you, keeping it exact. This is totally my fault. We should have crossed off this whole like round to 2 decimals. We should have totally erased that yesterday because I don't want you ever having a decimal unless it's a word problem. My fault that I didn't catch that that was there. So we're going to talk about solving 33 without decimals. And then we're going to look at 35 as well. So I'm going to start with 33. Get a smaller pen here. So we're going to work through this one, getting an exact answer because that will be the expectation. So can you work through it exact? Really, the steps are the same, except your answer shouldn't be a decimal. It should have a radical in it. So we have 12 minus the quantity, 2x plus 3 cubed, and that's 84, equal to 84. So, Julia, what's the first thing we would do if we're trying to solve an equation? Yeah, let's take that 12 to the other side. So subtract 12. And 84 minus 12 is 72. And this is a cubed here, not a squared. And then the next thing that I would want to do is get rid of that negative because that whole quantity is negative. No, it doesn't distribute through. I just need to divide it out and take it to the other side. So this is 2x plus 3 cubed, and now it's negative 72. So all of that are regular properties of solving equations. Now we have the quantity cubed, and to get rid of a quantity that's cubed, we do its opposite. That's why we have radicals to get rid of exponents. So Julia, this quantity cubed, to get rid of it, we would take, yeah, the cube root of both sides. So here's where I'm going to say we're going to keep it exact. Instead of putting this in the calculator, we're going to try and now keep this exact. So my cube and cube root cancel, leaving us just with 2x plus 3. On the other side, we have the cube root of negative 72. A cube root is odd, so whatever my number underneath is, if it's positive, my answer should be positive. If it's negative, my answer should be negative. But I want us to break this up and not get a decimal. So we are going to simplify this. And it's okay if you didn't do this because it's totally my fault. So my fault that I did not change those directions. What perfect cube goes into 72? Do you know, Julia? It is an 8. And I'm going to make that one negative since it's a negative 72. And then the other one would be 9. Negative 8 times 9 is negative 72. The cube root of negative 8 is? Yeah. And then we still have the cube root of 9. So if you got a decimal, is it probably easier? Yes. And that's what the directions said. But we are working with radicals and trying to simplify them. We spent a whole week simplifying radicals, so we're going to continue to keep things in exact form. So this problem isn't done yet because x still isn't by itself. So to get x by itself, now I have to just solve for the equation 2x plus 3. So I'm going to try and get x by itself. I know I got to subtract that 3 to the other side. I'm going to make that go in front. So the negative 3 is the integer. I'm going to keep the integer in front. And then I have that minus 2. And then the cube root of 9. And finally, to get x by itself, we have to divide all of it by 2. So my answer is negative 3 minus 2 cube root 9, all divided by 2. And you can keep it like that. Remember, if I divide one of them by 2, I have to divide the other by 2. So with the fraction, whatever you do to one thing, you have to do to every single part of the fraction, all pieces in the numerator and the denominator. So I know you're thinking, yeah, but the decimal answer of negative 3.58 seems so much nicer to me. Maybe nicer to the eye. Probably easier to work through. However, we are keeping things exact. And that'll be something that, like, moving forward in math, very rarely will you have decimal answers. It'll be exact at this point. We're in high level math. You're halfway through the year of Algebra 2, Honors Algebra 2. So anything above this, like, we just keep things exact, precise, instead of rounding. Any questions with solving 33 without getting that decimal value, using the radicals? So we're going to look at 35 as well. Let me bring this down. Of course, it's slanted, so it's not going to work. Try this one. Good enough. Okay. So this one, we have a cylindrical container that holds 20 ounces of fluid. So it's a cylinder. Container, can. Let's say it's a can. It holds 20 ounces of fluid. 1 fluid ounce is approximately 1.8 cubic inches. The height of the container is 3.5 inches. Use the formula for the volume of a cylinder to find the radius of the container. And I gave you the volume formula. The volume formula is pi r squared, because a cylinder is like a can. Think of a soup can. Like, that's essentially what we have. So you have the circle part, And then I need the height. So that's why it's pi r squared h. Pi r squared is the area of a circle. And then I need the height of the can to get the volume. Volume is space. They're giving us a can holding 20 ounces of fluid. Ounces of fluid is a measurement for liquid. How much liquid do I have? But it doesn't tell me the space that it takes up. So volume is the amount of space something takes up. A measurement of liquid tells me how many ounces I have of the liquid, but it doesn't tell me how much space it takes up. So in order to find the volume, Cody, what would you have to do with the information they give you to actually find the volume? So what do they give us in the problem, Cody, so we can find the volume of this container? Anyone want? Yeah?
First thing I did, this was from the homework, but I divided by 3.5.
So let's put that 3.5 in. What's that go in for? Yeah, all right. So 3.5 goes in for the H. So we're going to plug that in. We will be dividing, yes. What else can we plug in? And how do you get that?
You get 36 because it says 20 ounces of liquid is 1 fluid ounce is 1.8 cubic inches. So you do 20 times 1.8.
Yeah. So it's not just 20 because that's not volume. In order to find the volume, I have to take the 20 ounces and how much space that ounces takes up. So remember, volume is the space. And he said that number becomes 36. So pi r squared times 3.5. So that was the little trick in this problem. Cody then said he divided by 3.5. And we could also divide by pi. So let's divide by both of them, 3.5 and pi. And then you're going to get a number here, and I think the number is 3.6 maybe. I don't exactly know what the decimal is. I know it's 3 point something. But whatever value you get there, use the second answer function of your calculator because you need to take the square root of it. So I'm just going to leave this as 36 over 3.5 pi. But we're taking the square root of that entire decimal value. Again, don't round it. Use that second answer function in your calculator. So do the square root, second answer, and then your radius should be about 1.81. And then this was given in inches because I believe the height was given in inches. Yeah. Questions? So the little trick was to understand what volume actually means. Volume is space. Ounces is the amount of liquid that you have. That's how liquid is measured in fluid ounces, but it's a fluid. We need to know how much space it takes up. Questions? Good. All right, so as I said, we are going to continue working with rational exponents. You probably want to keep your calculator out, and I would say that common powers sheet, I don't know if I still have it. Here it is. This you're still want to have as like a reference because we're still working with these powers. We're going to be reducing radicals, reducing fractions, using the common powers. So you probably still want to have this handy somewhere so that you have it to look at. So in your notes, we are going to go to section 6.2. And we're going to start off with a little review of the properties of exponents, but we're switching it to rational exponents now. So instead of having x cubed and x squared, I might have x to the 1/2 and x to the 5/6 or something like that. So my fractions. So for a rational exponent, the properties say let a and b be real numbers, m and n be rational numbers. The following properties have the same names as those we did in lesson 5.1. Section 5.1 was when we did properties of exponents. The exponents were integers, positive and negative numbers. So we can apply those same properties to rational exponents. So Grace, the first property says I have a to the m times a to the n. What do you do with the exponents to combine them together? Yeah, you add them. All right, well, let's look to see what we have in the example next to it. If we add those exponents together, we have a half plus 3 halves. So Grace, 1/2 plus 3 halves is 4 halves or 2, yeah. So that makes 4 halves, or it makes 4 squared. So you can add them together because they have a common denominator. Remember, fractions, in order to add or subtract, must have a common denominator, and they do. So 4 halves is really squared, and 4 squared becomes 16. So make sure it's simplified all the way. The second property, this is our power of a power property. Grace, what do you think you would do with a to the m to the n? Yeah, multiply them. So we're taking those exponents and multiplying them. So we have the exponent of 5 halves. We're multiplying that by 2. I'm going to make it 2 over 1 just so that I can have it as a fraction. What is 5 halves times 2? Jaden, you know what 5 halves times 2 is?
It is 10 over 2, so that would be 5.
There you go. 10 over 2 is 5. And then we have to do 2 to the 5th. Again, we can't leave it like 2 to the 5th. So if you have that common power sheet, use it, plug it in the calculator. 2 to the 5th, Jaden, is 32. All right, so the next one. This is our product of a power property. Remember, when two things are being multiplied together, the power distributes through to both of those terms as an exponent. So this would say a to the m, b to the m. So that exponent just distributes through to both of them. So if I would apply that, distributing it to both of them, I would have 16 to the 1/2 times 4 to the 1/2. All right, now let's think about an exponent that is a fraction. What is 16 to the 1/2? How could I rewrite the exponent of 1/2? Thinking about what we just did in the last section. Ella? Yeah, so the square root of 16, and then, yeah, it has a little exponent of 1, but we know anything to the exponent of 1 is just the number itself. But the exponent, remember, the denominator is the index of the radical. So we're taking the square root of 16 to the first, or we're just taking the square root of 16 times the square root of 4. Ella, the square root of 16 is? And the square root of 4 is? And then you end up getting 16. Sorry, sloppy 16 there. So yes, we could have done that a different way. We could have multiplied the 16 times 4 together inside. Sorry, it's 8. Yep, I got it. Thank you. There we go. So we could have multiplied 4 times 16 together inside as well, and then taken the square root of that number. But wanted to show you that property and remind you how it works. All right. Number 4 is our negative exponent property. Gabby Snyder, when you have a negative exponent, what happens? Yeah, it becomes a fraction. So it goes underneath the power, not the power, the number 1. So a to the negative m is 1 over a to the m, which means that we have 1 over 25 to the 1/2, which is really 1 over the square root of 25. So anytime you see an exponent of a half, that's a square root. A radical and an exponent in rational form are the same thing. And we know the square root of 25 is 5, so that would become 1/5. So it becomes a fraction because of the negative exponent, and then we apply the exponent once it becomes positive. All right, 2 more to go here. Alyssa, what do we do with fractions you're dividing here? Do you remember what that property is with the exponents?
No, I don't.
Well, let's look. If you were multiplying, we added the exponents. What's the opposite of adding? Subtracting. The opposite of multiplying is dividing. So if we're dividing, we subtract the exponents. So dividing, you subtract the exponents. Multiplying, you add the exponents. So in this case, we have 3 to the 5/2 divided by 3 to the 1/2. Remember, the base has to be the same for this to work. So we're taking 5/2 minus 1/2. Which is 4/2 or just 2. And 3 squared is 9. So subtract those exponents, 5/2 minus 1/2. Denominator is the same, we can subtract them. And then the last property we have here, this is very similar to number 3, except this is the quotient with an exponent, the quotient of a power. So that power distributes to both parts of the quotient. A to the m divided by b to the n. So if we look at the example, 27/8 to the 1/3. Well, the 1/3 goes to the 27 and it goes to the 8. Ava R., how would you write the 27 to the 1/3 exponent? Yeah, cube root of 27, cube root of 8. What is the cube root of 27, Ava? And the cube root of 8 is? Excellent. Any questions? So those are a quick review of the properties. You can see how the last section corresponds directly with this section. So we're going to be working with exponents that are in fractions. We're going to change them to radicals, trying to get them to simplify. All right. The problems underneath are a little more interesting. If you look at letter A, use the properties of the exponents to simplify. Make sure it's completely simplified. Let's start with A. 9 to the 1/2 times 9 to the 3/4. So the base is the same. We're multiplying those bases. Jaden, what do you do with the exponents?
You have to make them have the same denominator, so you can multiply 1/2 each by 2.
So she said we need to make them have the same denominator because our goal is to add them together. We need to take 1/2 plus 3/4. So she said the first one, we would have to multiply the bottom by 2 and the top by 2. So that becomes 2/4. 1/2 is 2/4. Jaden, if you add them together, what do you get then?
5/4.
Yeah, you get 5/4. There it goes, a little slow. All right. Now, it would be so wonderful if you could be like, done, move on to the next problem. However, our goal is to simplify these completely. So using what we did in the last section, we have 9 to the 5/4. How could you rewrite that as a radical? So Jaden, how would we write that as a radical?
It would be the 4th root of 9 to the 5th.
Right, to the 5th power. And I'm going to keep that 5 with the 9. So we took the exponent. The denominator is the radicand. The numerator becomes the exponent. And now we're going to try and simplify this. The way we're going to simplify this is by not making 9 to the 5th a huge number. We're also not going to use the calculator. So I want you to go back and think about a variable. So just take a minute here. If this said 4 and then x to the 5th. So don't write this down. I just want you to think. What would you do to simplify the 4th root of x to the 5th? How would we simplify that? So we did this in our radicals. We just had this on the review on Tuesday, I guess. Jaden, how would you simplify it?
You would pull out one x, and then you would have one x left over.
Exactly. So 4 goes into 5 one time. So I pull out an x, and then I have an x to the 1st left over. Well, that's how we simplify variables. If I simplify a variable that way, I simplify a number that way too. It doesn't change just because it's a number. So Jaden, 4 goes into 5 one time. A 9 comes out instead of an x. And then you still have a 9 to the 1 left over because you have 1 9 left over. Now it's simplified as a radical. So I have 9 4th root of 9. Before we move on, are there questions? So we wrote it as a radical using what we did in section 6.1, and then we simplified that radical. A rational exponent and a radical move back and forth. All right, let's look at the next one. So these are all a little different. We have 7 to the 2/3 times 5 to the 1/6. All of that is in parentheses and it's cubed. Cody, what do you do with the exponent outside when you have a quantity inside that's being multiplied?
You multiply the 2/3 exponent and 1/6 exponent by 3.
Yeah, oops, switch my marker here. So we're taking 7 to the 2/3 times 3. 5 to the 1/6 times 3. I'm writing this out for you physically to see it. After you get used to it, you probably don't need to think about that step, and your brain will just calculate it. Cody, what is 2/3 times 3?
That would be 6/3.
Yeah, and 6/3 is? How about 2? I'll help you out. Yeah. So 6/3 becomes 2. And then Cody, the other one, 1/6 times 3 is 3/6. And 3/6 is 1/2. So we have 7 squared, which we know is 49. Cody, 5 to the 1/2 can be written as square root of 5. Look at that. I teach math because I think it's cool how things kind of circle together, but I mean, that makes me a nerd. I'm all right being a nerd. I'm fine with it. I can humor you and you can laugh at me. It's all right. Questions? All right, let's look at a couple more. See, these are fun. Letter C, we have 3 to the 5/6 and 3 to the 1/3. So using the properties, think about what you have to do with those exponents. I know I have to subtract them since it's dividing. Grace, what do we have to do to subtract these? Excellent. And I use the cheater method here. I just write it next to it. So multiply both by 2. And then when you subtract 5/6 from 2/6, you end up with, yeah. Oh, wait. 3/6, yeah. Sorry. So that's 3/6 or 1/2. And we know 3 to the 1/2 can be written as square root of 3. All right, one more on this side. This one looks like a fun one. So let's think about this a little bit. What do you notice about what's inside? Don't look at the number outside right now. What do you notice about what's inside? The exponents are the same. We haven't had anywhere the exponents were the same. So we have the exponents being the same. If the exponents are the same, what do you think you can do with the base that's attached to that exponent, Jaden? So the base is the number 16 and the number 4.
So
What do you think we could do with those if the exponents are the same?
would you just divide them, you know, cancel out?
Yeah, well, yeah, we're going to divide them. So we're going to take 16 divided by 4. And 16 divided by 4 is 4. Now the exponent stays there because it was 16 to the 2/3 and 4 to the 2/3. So it still has that same exponent. And now we have that exponent of 4 on the outside. So you are allowed to divide the bases if the exponents match up because they're like radicals. So I'm allowed to divide the bases keeping the exponent the same. So the next step, Jaden, we have 4 to the 2/3 and then the 4 outside. What do we have to do with those two exponents there?
So we multiply 2/3 times 4.
Yeah. And that becomes,
That would be 4 and 8.
perfect, 4 and 8/3. All right, so we're not done. Don't get too excited. If I look at what I did with letter A, we had 9 to the 5/4, and we rewrote it as a radical. We're going to do that again. So we're going to take this and we're going to write it as a radical. We have the cube root of 4 to the 8th. Our goal is to completely simplify these. So once you're done with it as an exponent, to simplify it, we need to flip it around. The question that you ask yourself, how many times does 3 go into 8? That number comes on the outside, and then whatever's remaining goes underneath. Ella, 3 goes into 8 twice, and then what remains underneath? 4 squared, yeah. There's still 2 4s left over. So 3 goes into 8 2 times with a remainder of 2. That 4 squared is our remainder inside. That remainder right there. So Ella, 4 squared in the front, we can change to 16. Underneath, we're also going to take 4 squared and make it 16. This is a good problem. Now, the last question you ask yourself before you move on. Is it completely simplified? Can it be broken down any further? Cody, you're shaking your head. Why can't we break it down further?
We can break it down further because 8 is 8 times 2 equals 16. So you take the cube root of 8, which is 2, and then on the outside, you have the cube root of 2.
Excellent. This is a really good problem. This totally elevates the problems that we've been working on. There's a lot of steps that we did just to get this stinking thing to simplify. So the last thing we have to do, we have 32 and then the cube root of 2. That is our final simplified answer. So if I look at the left side here, we simplified the radical part first using the properties of radicals. Then, the properties of rational exponents. Then we switched it to radical form and had to simplify that. So it's like 2 problems in one, a math teacher's dream. You're doing 2 types of problems in one problem. And that's what makes these tricky. So make sure you're fully simplifying. Don't just stop when you get to the exponent. That exponent then needs to be switched and simplified. Questions? So we are gonna look at the next page. I think you'll see that these properties, we've been working on these. And this is more of just a review, pulling this in. We have the product property, the quotient property. We've stated this property 3 times now. The product property of radical says if I have 2 numbers underneath the same radical, I can split them up into their own separate radicals, taking the nth root of A times the nth root of B. And we've used this. So we saw this property in section 6.1. We saw it when we were doing the radicals, just repeating the same property as a reminder. When we're dividing, I can divide them separately as long as we keep the index the same. So the key thing is the index must be the same in order to simplify. We have done these examples. They're here as a little review. So see if you can think about the 5th root of 27, the 5th root of 9. Part B is the cube root of 192 and the cube root of 3. And then looking at the 2 checkpoint problems. Think about what we would do with those. So try and get those 4 problems simplified. You might need to use your calculator to help. But when the radical is the same, you're allowed to multiply them. That's the product property. When the radical is the same, you're allowed to divide them. That's the quotient property. So compared to the ones on the front, these should seem a little better. Julia, 27 times 9 is 243. Is 243 of a 5th root? It's equal to 3. Like, whoa, way easier compared to the ones on the front. Grace, 192 divided by 3 is? And the cube root of 64 is? 4. Whew. In the checkpoint, looking at number 1, there's a couple different ways that you could do this problem, kind of thinking about just what you notice. So Ava, what do you think you would do to start the checkpoint number 1? So take that negative 1/6, pull it inside the parentheses. Ava, do you know what 6 times negative 1/6 is?
It would be negative 6 over 6.
And what is negative 6 over 6? Yeah, so that's just going to be a negative 1. And then 5 is also going to have a negative 1. All right, so that's that property where we can distribute the exponent through. Ava, both of these have negative exponents. What happens when we have a negative exponent? Yeah, so we would have in the denominator 6 to the first times 5 to the first, which is 1/30. Another way you could have done this problem is to start on the inside. If the exponents are the same, you can multiply the bases. So I could have multiplied 6 times 5, and we could have said that's 30 to the 6th power. So my base can multiply together if the exponent is the same. And then I could have still had that 1/6, negative 1/6. I get the same answer. It just depends what you notice. Looking at letter B, or number 2, not letter B, the square root of 245 over the square root of 5. Gabby, do you know what 245 divided by 5 is? And what is the square root of 49? 7. All right, so the last couple here, why don't we just quickly do A and B? I'm not going to define it. We've defined simplest form. Let's see if we can think about A and B yet. Simplest form means we should be able to break these down, which is what we were doing on the previous page. So you might need the little cheat sheet we want to break down 135, a perfect cube that goes into 135. And then we want to break down 128, a perfect fifth that goes into 128. Jaden, do you know what goes into 135?
Yeah, 27.
And then the cube root of 27 becomes?
3.
Perfect. And then the last one, we'll stop with letter D here, the fifth root of 128. Julia, do you know what goes into 128? You said 4, right? So that becomes? You're so close. What's the cube root of 32? It's just 2. Anybody have questions? We're going to stop there. We'll save those fractions. Whew, pretty good day in math. So just kind of peeking ahead to tomorrow, we are going to work with like radicals, which we've done. So we're going to talk about like exponents, like radicals, and then we're going to throw those variables back in. Again, we've done. So just kind of working with them as fraction form. We've been working on these, so hopefully tomorrow should seem pretty good, straightforward. Today, I think, was the harder of the 2 days. Have a fantastic day. Everybody at home, if you have questions, please stay on. Otherwise, have a great day.